If I were here for this lesson, I would have you guys work your way through it first and then us come up with your observations in the end. But considering I'm not here, we're going to do this together. So this is module 1.5, growing dots, is the beginning to geometric sequences. So an arithmetic sequence you added to get from one term to the next, or you subtracted by adding a negative. Geometric sequences is like the next topic. It's the next level up. So we were adding and subtracting, so now we're going to be multiplying. So if we look at this pattern, there's 3 dots at the beginning. At 1 minute, there's 6. At 2 minutes, there's 12. At 3 minutes, there's 24. At 4 minutes, there's 48. And it says, describe and label the pattern you see in the above sequence of figures. So at the beginning, at 0 minutes, I'm going to zoom in so it's not so sloppy. So at 0 minutes, there are 3 dots. Each minute, the dots double, which means multiplies by 2. All right, so it says, assuming the sequence continues in the same way, how many dots are there at 5 minutes? So we ended at 4 minutes. At 4 minutes, there were 48 dots. So we would write that a sub 4 equals 48. To find the next amount, you do 48 times 2. So 48 times 2 equals 96. So at 5 minutes, there are 96 dots. So recognize your pattern. This one is doubling. It's multiplying by 2. So we can start at the 4th term and multiply by 2 to get the 5th term. So the next thing, it says write a recursive formula to describe how many dots there will be after t minutes. So the recursive formula, I'm going to write the generic formula and then I'm going to have you guys, and then we're going to fill it in. So the generic formula for a recursive formula of a geometric sequence, so one that involves multiplication, it can be written one of 2 ways. So you have to always include your a sub 0, your a sub 1. We've gotten in the habit of finding a sub 1 and the rate of change every single time, so I'm going to include a sub 1 this time. Then you have a sub n equals a sub n minus 1 times the ratio. So to fill this in, you would end up with a sub 1, so at 1 minute, there's 6 dots, and then a sub n equals a sub n minus 1, so the previous term, times 2. So there is another way to write it, and this is the way that's on your formula sheet. So I do need to show you guys this as well, because on any standardized type testing, this will be the way that you see it. So when we have a sub 1 equals, and then a sub n equals r times a sub n minus 1. And r just means your ratio, what you're multiplying by. So up here, I want to label that as r equals 2 is your common ratio. So the common difference was the number you add to get from one term to the next. So the common ratio is the number you multiply by to get from one term to the next. So in this case, if we rewrote it the other way, again, it's the same thing. It's just a different way to look at it. So your first term is still 6. So a sub 1 just means the first term. In the first minute, there's 6 dots. And then a sub n equals, your ratio is 2 times a sub n minus 1. Sometimes you'll see that a sub n minus 1 in parentheses like it is on the formula I wrote. Sometimes you'll see it where it's just a coefficient. Either way is fine. So now that we've done the recursive formula, we're going to do the explicit formula. So the explicit formula, there are 2 different ways to write it, but only one way is on your formula sheet. I'm still going to show you both regardless. So the way I want you guys really emphasizing and using more often than not, because you're always going to have the first term, or you can find it. So we have a sub n. So to find any term in the sequence, you take the first term, you're going to multiply it by your common ratio, n minus 1 in the exponent. So because we're multiplying, this is like exponential functions. And in an exponential function, the x is always in the exponent. So x in the exponent, exponential. Exponential functions, you're multiplying your way through. So geometric is just like exponential, and your variable is going to be in the exponent. So when we do this, we're left with a sub n equals, our first term was 6 because there were 6 dots at minute 1. Your common ratio was that 2 you're multiplying by to get from one term to the next, and then n minus 1 in the exponent. Now, sometimes you may also see it this way, so I'm going to put a big or and show you guys the other way. So this is, the second way is written more like an exponential function where you have your a sub 0, which is like your y-intercept, times your ratio, which is like your rate, and just an n in the exponent. So when you're using the first term, you have to have that n minus 1 in the exponent to backtrack it. When you have a sub 0, you don't, because you're already at that backtrack step. So when you plug in what you know, a sub n equals, at 0 minutes, there were 3 dots, and we multiplied by 2 every minute.